Hello, I'm Greg Profizich from CMTC, a private nonprofit organization that provides technical assistance, workforce development, and consulting services to small and medium-sized manufacturers throughout the state of California. Today I'm here to talk to you about robotics and automation. My goal for this presentation is to give you an understanding of robots and cobots and how they may be of value to you to increase your company's productivity and competitiveness, now and for years to come. Let's start off by setting some context. What are automation and robotics? Automation refers to equipment or machinery that automatically performs its function in a manufacturing system or a production process. Examples are motorized conveyors, box erectors, custom machinery, and hard tooling. Robots are automated, programmable electromechanical mechanisms that sense objects in their environment and respond accordingly. Examples are robots performing pick and place, or machine tending, or sanding operations. The programming, sense, and respond aspects of them set them apart. Automation tends to have little sense and respond capability. For instance, a robot can sense that it placed a box on a pallet in a given position, and based on that information, will place the next box adjacent to or on top of the previous one. Globally, the robotics market has grown since the pandemic and is expected to potentially double in the next 5 years. In the near term, this growth is being driven by a number of factors. Among them are workforce issues and digitization. Before the pandemic, skilled labor shortages were a growing challenge to manufacturers. With the Great Resignation, this challenge has sharpened. Manufacturers are looking to have their skilled workers do tasks that require thought and experience, brain work, and looking to use robots to perform menial and repetitive tasks, movement work. This is expected to contribute to the growth of the robotics market. The other factor driving this growth in robotics is the digitization of manufacturing, often referred to as Industry 4.0, the Internet of Things, or the Industrial Internet of Things. Manufacturing has evolved over the last 250 or so years, from animal power, Industry 0.0, to steam power and mechanical automation, Industry 1.0, to industrialization, conveyors and assembly lines, Industry 2.0, to electronic automation, PLC controllers, Industry 3.0. to cyber-physical systems, Industry 4.0. It is believed that the digital integration of manufacturing assets and equipment like robots with manufacturing and planning systems will result in gains in productivity, efficiency, and throughput within work cells, value streams, and across supply chains. Let's talk about the parts of a robotic solution. When one buys a robot, what is usually being purchased is a robotic arm, a robot controller, and a programming interface, or teach pendant. A brand new robot out of the box will not have a hand connected to the robotic arm. The hand of the robot, called the end effector or end of arm tooling, is manufactured by different companies and sold separately based on the planned use of the robotic solution. For example, a palletizing application where boxes need to be stacked on a pallet, the end effector will often use vacuum and an array of suction cups covering much of the area of the box top to grip the box for movement. For machine tending uses, the end effector will often be a mechanical gripper, mimicking the capabilities of a human hand. If the robot will be used for welding, there will often not be a gripper, but instead a welding tool. There are a number of types of robots on the market that are well suited for certain use cases. So far in our discussion, we've only seen articulated robots. Articulated robots have rotary joints that allow for a full range of motion. This allows them to achieve very precise and controlled movements of enhanced flexibility and dexterity. As such, they can be deployed for a wide range of applications, as shown in the chart. Selective compliance assembly robot arm robots, SCARA for short, have arms with joints capable of horizontal movement. The wrist-like appendage has limited motion, which will allow it to be ideal for assembly work, like pick and place, kitting, packaging, and other material handling applications. Built from jointed parallelograms connected to a single base, Delta robots have a spider-like appearance to make delicate, precise movements that are useful in food, pharmaceutical, and electronic industries. They can complete highly repetitive tasks, such as small part assembly, quickly and precisely each time. Also known as gantry robots, Cartesian robots have 3 linear joints that move in different axes, X, Y, and Z. This unique rigid structure enables simple movements with advanced precision and repeatability. Since they do not require extensive movements, they are some of the cheapest industrial robots. Different types of robots have been created to do different types of work. Traditional automation solutions are highly appropriate for certain types of tasks, and this will always be the case. Cobots are articulated robots, but there are several important differences between cobots and traditional industrial robots. Cobots, or collaborative robots for short, are more affordable and easier to use than traditional industrial robots. What really distinguishes cobots from traditional industrial robots is their versatility, smaller footprint and weight, as well as the safety functions that enable collaborative operation. Traditional industrial robots also have extensive space requirements. The safety caging around traditional automation solutions can add 20 to 30% to a work cell's space requirements. Until recently, industrial automation required teams of dedicated expert programmers and application engineers, putting robots out of the reach of many businesses. But collaborative robots? They can be programmed to automate manual processes across many industries and can integrate into larger custom-built automation systems or existing production lines. Let's talk about some of the potential benefits of deploying robots in your operation. Deploying a robot can help you lower your operating costs. Do you experience chronic overtime in operations? Robots don't get paid time and a half. Do you have customer needs that you can't fill due to capacity constraints? Deploying a robot may net you additional production capacity and more productive time. If you invest in a robot, you can benefit from increased depreciation expense, reducing your taxable income, as well as IRS Section 179 deductions and benefits. Deploying a robot may allow you to increase product quality. Are there precise, repetitive operations on your plant floor where operators have difficulty consistently producing quality? The right robot, once properly integrated and configured, can maintain high precision and repeatability. Do you have operations that are mentally or physically taxing on workers? Deploying a robot may eliminate the opportunity of quality defects due to distraction or fatigue. Deploying a robot can consistently produce higher quality. Contrary to the misconception in the popular media that robots are going to steal people's jobs, deploying a robot can actually have the effect of improving the quality of work for your employees. Most employees don't enjoy the so-called dirty, dull, dangerous, and repetitive tasks. Stations with these tasks often have a low job satisfaction rating and may be difficult to keep staffed. Many workers are excited to learn the new skills as they are trained to set up, program, and maintain robots on the production line. Deploying a robot can free your workers up from mindless motion work tasks and allow them to contribute through more brain work tasks. Deploying a robot may help you increase production output. Robots can help you mitigate the losses resulting from the current shortage of skilled manufacturing workers. Are there stations in your operation where you need productive capacity but can't find the workers? Depending on the tasks to be performed, a robot may be the solution. Robots can help you achieve full shift production. Robots, unlike humans, don't need to stop working for breaks and meals. If a company's standard is to take 2 15-minute breaks and 1 half-hour meal per shift, installing a robot can result in 5 additional hours of production per week on a given workstation, which equates to around 250 hours per year. In operations where the machine time for production run is several to many hours, deploying a robot may allow you to run lights out. Lights out production is setting up a robot at an operation and running production after normal business hours. This can equate to thousands of additional production hours and equivalent units per year. So we have talked about what robots and automation are, the parts of a robotic solution, and where robots can best be deployed, the difference between robots and cobots, and the business benefits robots can provide. Now let's go over some common questions that executives often ask. How long does it take to deploy a cobot or robot? As with so many things, the answer is, it depends. One of the key constraints in the current environment is the availability of the robotic arm and end effector. If you already have a cobot with a configured end effector and are deploying it to a simple, standard application, programming and integrating it into your operation can take as little as a day to a week. If custom end effectors or custom fixtures and work-holding devices are required, or integration with multiple disparate production assets are required, deployment times will elongate. The main driver of deployment time is complexity. Complexity can come in a number of forms: size and shape of the part presentation, the number of steps the robot must perform, the interactions that the robot needs to have with other production equipment and systems, risks to surrounding staff of proximity to the robot, and safety considerations, to name a few. There are many more. CMTC's recommendation is to crawl, then walk, then run. Start with a simple deployment, ideally doing only motion work. Approach things from a minimum viable robotic cell perspective. Nothing fancy, no bells and whistles, so to speak. Deploy the robot and gain value from what it produces. In that process, your organization will gain valuable skills, understanding, and insights about where and how to target the next deployment. Another concern that many business leaders have is around the programming of robots. While it is true that training is required in order to have the skills to program standard industrial robots, that is not true with cobots. Most cobots can be programmed by writing code, but also by using the teach pendant to direct the movements of the cobot arm and the end effector as shown here. Essentially, if you can use a cell phone, tablet, or video game controller, you can program a cobot. Some cobots can even be programmed by physically moving the arm through the motion steps and recording the movements. For example, using the free drive mode in a universal robot. Once recorded, the program can be saved and then fine-tuned using the teach pendant. The global robotics market is growing at a significant rate. This growth is driven by a number of factors, including workforce issues and digitization. As we have discussed, robotics can be applied across a wide range of manufacturing operations and can drive improvements in employee work quality, product quality, production output, as well as reductions in cost. Knowing what you now do about robotics, click the link here to take a short survey and start your robotic deployment journey. If you have questions, please contact me by phone or email. Thank you for your time and attention. Stay safe and healthy.